Before we begin, I want you to try to imagine driving down a highway on a hot day. All of a sudden, the dashboard light comes on, forcing you to pull over. After reluctantly pulling over, expectedly knowing your car system has failed due to a most likely complex issue, on further investigation, you realize the culprit that has usurped you of the next couple of hours, or most likely entire day, is the simple yet very critical and common problem of overheating. Now, though this problem may seem applicable to only specific situations, I want you to try to recall the last time your laptop has frozen right before a presentation or before a deadline because of its components beginning to overheat. This is due to the same problem of overheating. Overheating is, though seeming like a temporary problem, has long-term consequences such as reduced efficiency and shortened lifespans of mechanical systems. Meanwhile, consistently costs companies and consumers substantial amounts of money to deal with. With this being said, this issue, as you may have presumed, has pervaded the engineering world for decades, with many focuses of engineering having to find their own personal solutions to the problem with how it specifically affects them. Hello, my name is Ada McBarnaho, and I'm here to present a way to combat the silent killer, overheating. First, I'm going to define and describe the biggest issues of overheating. Then I will cover a solution to overheating, and then I will discuss the solution's real-world applications. Now, let's move into the issues of overheating. Since far before the common problem of overheating in electronics, the problem of overheating in general has always been a problem. During the era of steam-powered machines, overheating was a constant issue as systems producing excess amounts of heat would lead to dangerous buildup in pressure in engines. This would become a problem as the pressure built up in the engines could very likely explode, as this entire system works off of steam and pressure being produced, which would allow the engine to work in general. But if a large amount of pressure was released at one time, the entire engine could just explode or just break. With this being said, heat building up in the same type of engine, pooling together in one specific component of the engine, could end up damaging one part of the engine, as it would warp that specific piece, leading to the same issue of the engine just not working. Coming back to the modern day, however, we are still able to see overheating and its detrimental effects in our engines. Things like warped cylinder heads, blown gaskets, and cracked engine blocks. Though these would occur at certain points, are more likely to happen when heat is added to the equation. The issue of overheating revolves around heat, a natural part of these systems, being trapped within the system and not being able to be dissipated, resulting in it traveling to various parts of the system and pooling in them, which would lead to them being warped and deformed. Small amounts of heat are typically insignificant. However, heat in excess could result in structural warping of the components, as I just mentioned. The commonality of this issue is defined by eastwood.com claiming that nearly 10% of drivers would experience the heat-related issues in their lifetime. Now that we are able to observe the issue of overheating, I want to look at a fix for overheating. So overheating being a common issue throughout the engineering world has several solutions and several applications. From coolant to heat sinks, from fans to water pumps, overheating has been tackled for years with various solutions. However, these solutions have had limited success in allowing the mechanical systems they were created to enable run, but not in stamping out the problem of overheating completely. With this being said, a different approach has been utilized when attempting to solve the problem called phase changing material, or PCMs. PCMs are materials in which, when liquefied, absorb heat and release heat when solidified. As the material has the ability to absorb and release great amounts of energy, they have the ability to stabilize temperatures very efficiently, allowing for systems to run with only consideration to far greater deals of heat that would make the amount of heat we currently consider insignificant. Having the ability, I would utilize this technology in the field of mechanical engineering in the engines I would build for various machines, as it would take away one more consideration I would have to make. While this is true, a statistic defines that PTMs have more uses than just in engines, claiming PCMs can achieve up to 35% reduction in refrigeration energy costs. Now that we have covered a solution to overheating, let us observe its uses so far. As right now, PCMs have not been used all too commonly, having mainly been used in the production of smartwatches. However, experimentally, research regarding the technology's lifetime as well as heat storage capacity are currently being taken. With this being said, PCMs have been out of a number of things that they apply. PCMs have been out of a number of things been applied to applications of HVAC systems, in which they were integrated into wall boards, panels, flooring systems, where these systems were able to see a 4 to 7% energy reduction in the buildings that they were applied to. This truly underlines the efficiency and wide application of this new cooling technology. Now that we were able to cover the issue of overheating, the new technology of PCMs, and the applicability and efficiency of PCMs, we are now able to truly understand and see the significance of the roadblock of overheating and the possible technology that may allow us to move past the roadblock of overheating and arrive in a new technological era, one without the barrier of overheating. Thank you.